Welcome to today's ArcGIS tutorial. I am Abhradip Bishwas here with you. Currently, I am studying in Khulna University of Engineering and Technology. Today, we will learn about the project tree, that is flood depth analysis. Let us see the project details. So, we are given the following spatial data sets with BTM projections for the eastern part of Bangladesh. We are given digital elevation model, that is raster file, the fault line, that is a vector file. We have given water level, river, and Thana boundary, that is also a vector file. So the questions are: we have to generate a flood map and classify flood as per the FFWC category. We have to find out the flood statistics for each category, and then we have to identify the extent and magnitude of flood for each Thana and generate the statistics. Then we have to show the settlements under various flood categories, and finally we have to compose a A4 size map showing the flood extent and magnitude for each upazila of eastern Bangladesh. So you can see we have loaded the shape files and rasters in the ArcGIS software. Now we will start our analysis. So firstly, we have to load the water level spot values. For that, we need to add it in a different method. So we have to go to the Excel file, double click in it, then we have to go to the flood points and add it. Then to show it to the map or in the display, we have to click on display XY data. Then in the X field we will select point X, Y field we will select point Y, and the Z field we will select point Z. Then we will click OK. Now you can see the flood or water level points are displayed here. Now you can see the flood points or the water level values are not covering all the area of our dam. So we need to use interpolation to cover it to all the area of the dam. For it we will search the IDW interpolation. There are different interpolation techniques, but for this particular problem we will use IDW. So we'll click here, and in the input point features we will select the flood point events. In the Z field value we will select point Z, and for the output raster we will save it as interpolation.pif. Next we will just select the input barrier. So the input barrier we will just restrict the interpolation parameters in the certain areas where it is not needed. We will select fault line in the input barrier. Next we have some tasks in the environment fields. We will go to the environments. In the processing extent we will select the dam layer in the extent. In the snap raster we will select dam as well, and in the raster analysis field we will select dam in the mask, and cell size same as layer dam. This is done in the environment settings, and click OK. Then now you will see that the output cell size is automatically adjusted based on the dam raster. Now we are ready for the interpolation. We'll click OK, and the interpolation will take a long time. I will fast forward the video. So you can see that our interpolation is completed. To get the actual flood depth or the area that will be engulfed by the water, we need to subtract these two raster layers. We'll go to the raster calculator and then we'll select the layers. We'll subtract them from the interpolated raster. Then we will name it flat levels and then click OK. Sorry, we have a problem. We need to give an extension that we haven't given previously, that is .tif. Now it will work. Yes, so you can see that our actual flood depth or the area underwater is showing here. Now to visualize the flood levels according to the FFWC category, we need to change the symbology of it. For it, we'll go to the properties and then we will choose classified. We will choose 6 classes and go to classify. Now we will follow the value in these categories and put it here. So the first value will be 0, then 0.3, then 0.9, then 1.8, then 3.6, and then we'll put the max value, that is 10.4510941, and then we'll click OK. Now you can see that it is classified, or we can actually label it, like the first one is FF, the second one is F1, then the third one is F2, then F3, then F4, and sorry, we'll go with 0 first. F1, F2, F3, and last one is F4. Now we will choose color ramp. I guess this one will be good. And since this range will not contain any vulnerable depth levels, so we will just change this range symbology later on. So first we will apply it and click OK. Then from here we will just make it white. Now you can see the flood levels are symbolized as in the flood depth parameters. Now for the further analysis, we need to reclassify this raster in order to introduce the attribute table inside of it. So we'll search for reclassify and we'll click here. Then in the input raster we will select this flood level and then we'll classify as we have done in the symbology panel. So the first value will be 0, then 0.3, then 0.9, 1.8, 3.6, and the max value, that is 10.405109. Okay, we are done, and then we'll click OK. And in the output raster we'll save it as flood levels dot diff, and then we'll save it and click OK. Now you can see that we have this layers, and this symbology. The symbology doesn't matter now. We need to analyze the data. So in the value field is actually showing us the flood levels, that is here. So we will just edit this layer, this attribute table, sorry. So for this we need to add some fields. First we'll add flood status, that will be text. Okay, then we'll add area, square kilometers. We'll take double and click OK. Then we will add percentage. We'll take float and click OK. Now uh, in the value, one is showing ff, so we'll write ff here and follow the other values down here. So we'll go to the editor and start editing. We'll edit the pre-classified flood levels. We'll click continue. Now we can edit here. The first one is ff, then f0, f1, f2, f3 and f4. Now for the area of square kilometers, we need the raster resolution because it is a raster. So we can go to the properties, and in the source we can see the raster resolution is 300 by 300. So to calculate the area square kilometers, we have to go to the field calculator, and first we need to enter the count, then we have to multiply it with 300 into 300 because every cell's resolution is 300 by 300. So next for kilometers, our data is given in meters. For kilometers we need to divide it by 1000 twice. Now we'll click OK. So you can see our area square meter is now showing. Now for the percentage, it is easy. We just need to go to the statistics of area square kilometers. We need to copy the sum, then we'll go to the percentage field calculator. We just have to turn the area square kilometers, then we'll divide it by the total sum that we have copied previously, then we will multiply it with 100 and click OK. Our percentage is showing here. So our basic statistics are done. We have primarily generated some statistics, but if we want to show the statistics based on the Thana boundary, we have to intersect this layer with Thana boundary, but this is a raster layer and Thana boundary is a vector layer. So first we need to convert this raster into vector. For this we'll use raster to polygon tool. We'll click here, and for the field of input raster we'll choose reclassified field vector. For the field we can choose class statistics, and for the output we can choose poly plot, just name it anyhow. So sorry, this is not adaptive, this is a shapefile. So this is done, just click OK and it will generate a shapefile. So our shapefile is generated. Now we just have to intersect it with the Thana boundary. You can see the Thana boundary here, keeping it in the top. So we'll go to the geoprocessing, intersect, and we'll choose Thana boundary and polyflood, and we'll save it as intersect Thana, and we'll click OK. So you can see the intersection is done. Now if I open the attribute table, you can see that the area is not showing, actually the polygon area. These are the Thana areas. So to show the actual area or calculate the actual area, we need to add a new field. We'll add area sq. We'll take double, click OK. Now we'll simply just calculate geometry and select the unit as square kilometers and click OK. You can see the area is generated. Now we can move to Excel to individually show the flood statistics for every Thana. So you can see we have come to Excel. Now to show the statistics, we need a pivot table. So we'll go to the insert and go to pivot table and click OK. In the rows, we'll choose flood statistics, and in the columns, we'll choose the Thana names, and we will choose the area square kilometers, the new one. Actually, in the values, we can show it as percentage. So first we are showing the percentage as the total area of all the Thana. So for this we'll choose the grand total, percentage of grand total. uh, for better visualization, we can just swap the layers like this. It is now looking better. So you can see the Thana-wise flood level analysis or flood level statistics in here. Now if I want to generate flood level statistics for every Thana, we just need to change the value field settings, and we just need to choose percentage of row total instead of percentage of grand total. Now it will show 100% for each Thana. So our primary statistics for Thana flood levels are completed. Now for the fourth questions, we need to show settlements under various flood categories. For this, we just need to intersect the poly flood level layer and this BGD settlements layer. So we'll go to the geoprocessing and go to intersect. We'll choose poly flood and this layer, and we'll name it settlements flood and click save and click OK. Now we just need to go to the attribute table, and you can see the settlement size is displaying here, like this field is the settlement size. So now we will copy the data and move to Excel. In Excel, we'll again go to the insert and pivot table, click OK. So in the rows, we'll select the flat stats, and in the values we'll select the BGD settlements. So now we can tell that how many people are actually residing in different flood levels. Now the final task that is left for us is to generate map for each Thana. To generate map for each Thana, we need to visualize the Thana boundary. We'll make it hollow and change the outline color into red. Just make it a little thick and then click OK. So now we want to label it because we need to show the Thana names in the map. So we'll label features. You can see that we have labeled the features. Now to generate uh, each map, it will be lengthy if I do one by one, because here exist 72 values. So we will use a tool that is data driven page. To find it, you need to go to customize toolbars and now data driven page. I have already selected it, so I'll move to it. Just go to data driven page setup and change the data frame to layers. Thana boundary, name field will be Thana name and sort field will be FID. Just keep it as it is, and in the extent we'll use the default values as well, then click OK. Now we need to go to the layout view because we will generate a map. Now we have to generate a insert map as well. To generate the insert map, we first need to insert a new data frame. In the data frame, we'll copy this Thana boundary layer, paste. We'll just make it a little smaller and we'll fit it here. So it is looking awkward. We will fix it. Just unselect it, the label features, and now if I select one Thana from this attribute, suppose we will select Amirganj, and from here we will zoom to the selected features. If we click it, you can see the map is now properly showing. Now we just need to fix it a little bit, then just we can make this symbology to like yellow and zoom out a little bit. So it is looking good, I guess. Now with this selection on, we need to show this map into the Thana boundary map. So to do this, we'll go to the data frame properties, and in the extend indicators we'll just swap this layer into this one and show leader and use simple extend and click OK. You can see the location of Almiriganj is showing in the Thana boundary map. So this is what we want. Now if we just move it a little bit, the map, it is showing good. Just make it a little smaller. And it is okay. Now we want to show the Thana name. For this, we go to the page text and data driven page name. You can see this is the text we want, so I'll make it larger, like changing the symbol like that, and we will make it like 24, and we'll change the color to this red and click OK. So this is our name. I'll align it here. Just change the font, just keep it Arial. It's looking good. So this is our name and we want a page number. So for the page number, click here. Here is the number that is generated. We'll go to its properties as well, change the symbol, make it 24. Let's choose a dark color, dark navy or a little lighter, then choose bold and click OK. So this is our Thana name and this is our page number. Now we have the extent indicators as well. Now we can print this map. For printing, we'll just go to the page and print setup and make it A4 because we have to print it in A4. Just adjust the things a little bit. Now we will go to the file and export map. So we will print it in PDF, but it will generate only one map. To generate all 72 maps, we need to go to pages and select all 72 pages, and resolution will be 300 and the best quality we need to achieve. Then just name it 72 maps and save it. It will start generating the maps. I will just fast forward. So you can see that our map generation is completed. Now we will just open the map and see the output. So you can see this is our map here. There are all 72 maps here. You see, all are generated properly. So this is all for today. Thank you for watching.